All right, guys. Once again, no face. That's okay. It's a little weird. Okay, so our goal today is, in this video, I'm going to give you one trig value. Okay, so just one trig value instead of two. So far, we're used to you give me two trig values, I'll find the other four. Well, now it's going to be one trig value and then some other condition that tells me something about the angle. Okay? And then you're going to find the other five trig values. All right, so let's dive in. Okay, so before we do our actual first example, it is important that you know kind of what the signs of the trig functions are and why. Okay, so I'm just going to there are lots of mnemonic devices and videos that you can watch that have something to do with this, but I'm just going to kind of tell you that we know the x value and the y value are positive in the first quadrant. So all of the trig functions, all trig values, okay, the outputs, are positive in the first quadrant. Easy peasy. Okay, so now the question is which ones are positive elsewhere? And I'm just going to list the positive ones just for the sake of kind of keeping this diagram clean. Sine, remember sine is my y value. So if my y value is in the first or second quadrant, sine of theta will be positive in the second quadrant. Ooh. Erase that. That's a weird. I don't know what happened there. All right. So sine is positive. Cosine, because it's the x coordinate, cosine is going to be negative. Cosine of theta will be negative. And then tangent, anytime you have a positive divided by a negative, tangent's going to will be negative. Okay, so I'll let you know that when you take the reciprocal of sine, if it's positive, it's still positive. So I'm not going to deal with cosecant, secant, and cotangent. I'm just going to deal with the first three. Okay, so third quadrant, well, x is negative, y is negative. So sine and cosine are both negative. Now, once again, I'm not telling you anything you don't already know, but it's important to just be able to crank through these quickly. Tangent of theta. Tangent is a negative over a negative, y over x, a y value over an x value. So tangent is positive in the third quadrant. Sine is positive in the second quadrant. Okay, they're all positive in the first quadrant. Then you have cosine, sine. So let me write this up. So sine of theta, it's my y value. It's below the x-axis. It's negative. Cosine, that's my x value. It's going to be positive. And tangent, just like in the second quadrant, if you have a negative over a positive, one negative when you divide is going to be negative. Okay, so positive, positive, positive. So there is this mnemonic device that I never really used. Personally, I just didn't use it. I was always thinking if I move up, the y value is positive. If I move left, the x value is negative. So I was just thinking visually, but there is this mnemonic device. As you wrap around counterclockwise for your angle theta, and it is all students take calculus. And if you're thinking, that's not going to be helpful for me, that's kind of how I felt. But teachers love to write it. All students take calculus. All are positive. Sine is positive in the second quadrant. So first quadrant, all are positive. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. And in the fourth quadrant, cosine is positive. So all students take calculus. The only reason I'm talking about this is it's like cultural residue. It's like you don't want to get to calculus and never have heard all students take calculus, because you're sitting there, why didn't my teacher show me that? And then I feel bad. So there it is. If it's useful, awesome. If it's not, okay. And there are other mnemonic devices. I always did use SOHCAHTOA, and I still use that. Okay, so that's another mnemonic device. It's a way to memorize something without actually memorizing it. So it's a trick to help you memorize. So all students take calculus, take it or leave it. There's a video in the notes that basically does what I just did. It was an okay video, so check it out. All right, so that takes us to our first example. Before we really dive in, I do want to just kind of crank through some more arithmetic. So let me just tell you guys this. If you really already know how to do problems like this and you feel absolutely 100% solid with the simplifying, canceling out, reducing fractions or simplifying fractions, then skip example 1 and go to example 2. But I'm going to run through another one of these because these are the kind of problems that give people fits because of the strangeness of the numerical values. So, given these two trig values, find the other 4. Okay? So, let's do that. Let's start with tangent. Tangent of theta is y value over x value. Now, I'm going to say this. We know that those 5s cancel out, so I'm going to stop writing all the 5s. Okay? I'm just going to take numerator and put it over numerator. Be careful with signs. So I'm going to write root 5 over negative 2 root 5. Once again, the reason I did that is I know the 5s will cancel out. Okay? Now, root 5 over root 5 reduces. There's an understood coefficient of 1, so those root 5s cancel, and that gives me negative 1/2. Once I find tangent, I'll go ahead and find cotangent. The reciprocal of negative 1/2 is negative 2. All right, so now to cosecant. Sine and cosecant, reciprocals. So invert and rationalize. 5 root 5 over 5. Root 5 times root 5 is 5. The 5s divide out. Root 5. Okay, so I have 1, 2, 3. I need one more, which is secant. Secant of theta is the reciprocal of cosine. Negative 5 over 2 root 5. I'm going to rationalize. Okay, so 5 root 5 over root 5 times root 5 is 5 times 2 is 10. And don't make the mistake that I almost made. Be careful with the details. So negative. Okay, and then be careful. 5 over 10. Those are rational components, okay? You're treating this no different than negative 5x over 10. You're using a radical. A radical is like some unknown quantity. What's the square root of 5? It's 2 point something. Nobody knows the square root of 5. Nobody knows it. We know what it's close to, but it is irrational. People were killed for the square root of 5 3,000 years ago in Greece, the Pythagoreans. I can't make this stuff up. Go to historychannel.com. Crazy stuff. So 5 over 10 is 1/2, so this reduces to 1/2. So negative root 5. So I get negative root 5 over 2. Final answer for secant. So I have found, I was given 2 values, 2 trig values. I found the other 4. So secant is negative root 5 over 2. Okay? So now that really takes us into kind of where we want to go with the lesson. Okay, so that was kind of, if you can do what we just did, that's kind of the majority of the problem, but there's this new component. Let's look at it. All right, so now, if I give you one exact value, you have to find the other 5 values, but the first thing you have to do is determine. It's all about theta. You have to determine where theta lives, which quadrant it lives in. That's the challenging part. That's the new part of the problem. Once you know where theta lives, you're going to draw a picture. I've said this in class. I'll say it again. My one and only complaint about Delta Math so far, other than the partial credit thing, but we'll work through that. I like that, actually. It forces you to go back and look and see what you did wrong. Email me, get your points back. I kind of like that. So when you draw the picture, Delta Math is going to lead you astray. Delta Math is going to call theta inside the triangle when theta is not inside the triangle. Inside the triangle is the reference angle with respect to theta, but I'll talk about that in class, and I'll talk about that in the video. So once you know where the angle lives, you're going to draw a diagram, okay? And then you're going to find the third side in the triangle, so you'll always be given two of the sides in the triangle indirectly, right? Always, and once again, this is pet peeve of mine, always simplify fractions no matter what without exception. Always rationalize no matter what without exception. I don't have to tell you that. I don't have to tell you to simplify fractions. I don't have to tell you to simplify radical expressions. I don't have to tell you to rationalize denominators. So all of that is understood. It's in the directions, but it's kind of understood. So be careful with that in delta math always. Now, once you've found that third side, you're basically back to the problem we just did, and you find those other values of the trig function. Okay, so that's what we're going to do. Determine the quadrant, draw a diagram like we've done in the past, find the third side like we've done in the past, and find those other trig values. So let's dive into an example. So this is kind of what the problems look like. I'm already given one exact value for a trig function. Sine of theta is 1 over 3. But then I'm not given another trig value. All I'm told is that cosine of theta is less than 0. Now, that's just an indirect way of saying that implies that cosine of theta is negative. Okay, so cosine of theta is less than 0, negative. Now, all I'm doing in this first slide is showing you my thought process. Okay, I know if cosine is negative, then my x value is negative. That means I'm going to be over here either in the second quadrant or the third quadrant. I can't be here. I can't be here. It's impossible. If cosine is negative, I have to move to the left. Okay, but my sine value is positive, which means that my y value is positive. Okay, so the rationale for being in the second quadrant is if sine is positive, I have to be up. If cosine is negative, I have to be left. Well, up and left takes me into the second quadrant. Okay? Now, so that's the first thing you do. Determine theta. I don't know what angle theta is, but I know that it lives in the second quadrant. That's going to help me draw my diagram. That's going to help me find my x values and my y values and such. Now, another thing you need to know, just want to remind you that sine of theta is y over r. Remember, radius isn't always 1 anymore. And cosine is always x over r. Well, indirectly, I was given two of those three values. So in this problem, I don't know what x is, but I do know that y is positive 1 and r is positive 3. Okay? And just to remind you, in a diagram, okay, I'm just going to do this. This is going to be very rough temporarily. I'm going to draw this really nice in a minute, but I just want to remind you, I don't know what my x value is. I do know that my y value is 1, and I know that my radius is 3, which is my hypotenuse. So, I just want to remind you, we now have x squared plus y squared equals r squared. That will never change. I just want to remind you that. That is always the Pythagorean theorem. The Pythagorean theorem is always hiding in these problems. I was given y, I was given r, and I have to find x. Okay? So in this problem, I don't know x, but I do know that y is 1. I do know that r is 3. So I need to find x. Now this is crucial. This is why the knowing where theta lives is so important. When you take the square root here, this is what we should have been doing, and we still should do it. There are two solutions to that equation, but only one of them makes sense in this problem. So the x coordinate could be positive or it could be negative, but the only one of those that makes sense in this problem is x has to be negative. So at x, will be the negative root 8. X will not be the positive root 8. Okay? So, negative 4 times 2. Okay, so 8 is 4 times 2. So this simplifies to negative 2 root 2. All right? So the x-coordinate is now known. So I'm gonna move slides and resketch all of this. So I know that sine of theta was given to be 1 over 3. That was my y and my r value. I found cosine, which is x over r. I found x to be negative 2 root 2. So I'm looking pretty good so far. But I need to make a sketch of the diagram. This is where, when you do this handwritten work, you have to be very particular. So I know that my y value is 1, and I know that r is 3, and I drop my triangle. So I know I have a triangle here, a triangle here. So I know that this is 1. I know that this coordinate I found to be negative 2 root 2. That's my x value. My y value is 1. I know that my r value, my distance to the point, is 3. And here is where I'm not a fan of what delta math does. Okay, I know that the x-coordinate is negative 2 root 2, but the actual side length is 2 root 2. Okay, and then here's where lots of points get lost. Put a big star by it in your notes, guys. Don't do this. Theta is not living in the triangle, guys. Theta is... There is theta. Delta math doesn't say that. Delta math will lie to you. Delta math will call this theta, but I'm reminding you that that is theta sub r, which is the reference of theta. So theta, remember, theta is, we said theta was in the second quadrant. So we've got to draw it as if it were in the second quadrant, because it is. Okay, so all over here, students kill this. They get it right. They find everything. The diagram gets people, so be careful. Label the coordinates as positives and negatives. Label your triangle using positive numbers only, because lengths or distances must be positive. And if theta's in the second quadrant, draw your little hooky. If theta's in the third quadrant, draw your little hooky. Don't call theta in the triangle theta. That is the reference of theta. Okay, so I've talked enough about the diagram. Big deal. Really practice that. If you're not sure about that, send me diagrams and I will say yes, no, almost, and I'll give you feedback. This is where a lot of points are lost when I teach this course, so be careful. So now we're back to the old stuff. I know sine, I know cosine, I can find tangent. Now, once again, I'm not going to use the 3's because I know the 3's cancel out. Or just go straight to the definition. Instead of using tangent of theta as sine over cosine, use y over x. 1 over negative root 2, negative 2 root 2. So that's the intermediate stage that I'm going to use in a minute. I'm going to rationalize root 2 over 4, so negative 4. Doesn't matter where you put the negative. I know some people are crazy about that. Not me. It's all good. Cotangent of theta, reciprocal. So I'm just going to flip that and get negative 2 root 2. Okay, so we found tangent. We found cotangent. Sine, I'm going to find cosecant of theta. Reciprocal of 1/3 is 3. Check. Done. And then I'm going to find the reciprocal of cosine, which is secant. Reciprocal, 3 over. Don't forget your sign. That's where lots of mistakes are made. It doesn't matter where you put it. I generally put it on top, but sometimes I forget, and I just drop it in. It's all the same. Rationalize. Negative 3 root 2 in the numerator. Root 2 times root 2 is 2 times 2 is 4 in the denominator, and done. So I was given one trig value and enough information to determine where theta lives. And once I know where theta lives, I know the sign of the x value. I did not know x. All right, I knew y and I knew r. I had to find x. But because we were in the second quadrant, my x coordinate was negative. That's where most of the mistakes happen. Okay, so let's try another one. Last example, and then we're going to talk about a couple of really important, just details you'll use to solve problems. So in this problem, I know cosine of theta is negative 5 over 7, which is x over r. So I'm told indirectly that the x coordinate is negative 5. I'm told the y coordinate is, I don't know, I need to find it. And I'm told that r is 7. Just to remind you now, r is always positive. R is a radius. R is a hypotenuse. R is positive. So if that fraction is negative, that sign goes with the x or the y, whatever it happens to be, in this case x. So first thing I'm going to do, this is scribble scrabble, remember? I'm not drawing anything elaborate yet. I'm just trying to determine where theta lives. Theta's in the third quadrant. That was pretty easy. So theta is in the, so I'm somewhere, and I never draw this to scale. And you notice delta math certainly doesn't. If you really pay attention, they'll have some crazy stuff. Example, they'll have 5 is this, and then this is 22. And you're like, there's no way that's 5 and that's 22. But they'll draw it that way. And we're not looking for scale. We're looking for position. So don't worry about where you drop stuff. So theta is in the third quadrant. As long as I draw theta in the third quadrant, I'm good. My x-coordinate is negative 5. So my x-coordinate is negative 5. My y-coordinate has not been found yet. Okay. So I'm going to draw my triangle. Once again, my x value is, my x-coordinate is negative 5, but my length, my base length is 5. My r value is 7, and I do not know y. Okay? Now, if that's your drawing, if that's what you give me on a quiz or a test, that's perfectly fine. This was initially going to be scribble scrabble, and it's actually okay. I'm okay with it. Now, some of you are much neater than others. I'm okay. That'll work. That'll get me what I need. So I'm going to go ahead and find my y-coordinate. Pythagorean theorem is built into every problem. Negative 5 squared is 25. Careful there, lots of mistakes happen. X squared is always positive, or 0. R squared is 49. Subtract 25 on both sides. Take the square root, plus, minus. Remember, the algebra tells me there are two solutions, but the geometry, right, the conditional statement tells me my y-coordinate is in the third quadrant, which means of these two possibilities, geometrically, this one is impossible. Okay, it's extraneous in this context, in this situation. So I need to rationalize, simplify the radical. Negative 2 root 6 is my y-coordinate. Okay, so that tells me that sine of theta is negative 2 root 6 over r, which is 7. Okay, so I've learned the new lesson. At this point, you've seen the new lesson. Okay, so that takes me to another slide where I can show some more work. So cosine of theta is negative 5 over 7. Sine of theta we found to be negative 2 root 6 over 7. So now I just find the other 4. Okay, so now it's just being careful and doing arithmetic. We had the diagram before. So it's going to be y value over x value. So y value over x value. Negative over negative is positive. Be careful. Delta math does not give any slack where negatives and positives are concerned. Neither do I, so be careful. All right, tangent, cotangent, reciprocal, 5 over 2 root 6. Rationalize. Guys, if you learn anything, you're learning how to rationalize. Root 6 times root 6 is 6 times 2 is 12. Finished. Okay, so now cosine has a reciprocal of secant. The reciprocal of negative 5 over 7 is negative 7 over 5. Be careful with your signs. The reciprocal of sine is cosecant. It's a weird abbreviation. I had a student call it kasuka one time. I was okay with that. That was very amusing to me. Okay, so the reciprocal of sine is kasuka. I'm going to flip it. And guys, I miss being in the classroom because I'm silly all the time in the classroom, but not so much virtually. Okay, so cosecant of theta is this value. I need to rationalize. And I get negative 7 root 6 over 12. Done. All right. So that is the second example. Looking good, guys. All right, guys. So that takes us to a quick lesson on even and odd functions. And this is not just some cute little, okay, that's great. Now what? That's not, I mean, this is actually extremely useful. So not only am I going to teach you what it means to be an even function and an odd function, where trig functions are concerned, but I'm going to show you how you can actually use it because it is very useful. This will save you a lot of time and frustration if you use it carefully. Okay, so you're given all 6 trig functions across this paper. So I'm going to cross this out. Don't do this. Don't do this. I'm just doing this for the sake of the presentation. I'm going to focus on the 2 that are in that middle column. I'm going to focus on cosine and therefore the reciprocal secant. So really, you don't need to memorize secant, but you do need to know cosine is an even function. So under here, just write even, and I'm going to show you what that even means. An even function by definition is this. I'm going to do an example. So I'm going to show you numerically what it means, algebraically what in the world that even means, because that's an actual sentence. That is a long, convoluted sentence that I'm going to unpack real quick, because that algebraic formulas say a lot more than it looks like on the surface. This is a deep statement. I'm going to show you numerically. I'm going to show you graphically what it means, and then I'm going to write a verbal way to memorize what even means. So here it is. Cosine of 60 degrees. I'm choosing 60 on purpose. So 60 degrees is here. Cosine of 60 degrees, right? We already know that that's cosine of 60 degrees is 1/2. Kind of already know that. Numerically, okay. Now, what's cosine of negative 60 degrees? Here's what's nice about an even function. If I go negative 60 degrees, which is in the opposite direction, the x-coordinate doesn't change. So this will save you a lot of time. If you're trying to find cosine of a negative angle, you can, in essence, drop the negative and get the same answer. So here's what we just said. An even function says if you plug in opposites, 60 and negative 60, 100 and negative 100, it doesn't matter what those opposites are. If I plug opposites in, I get the same number out. So let me write that here. Opposites in, same output. That's what this statement actually says. It says if you plug opposites, theta and negative theta, into the cosine function, the outputs are equal. That's what even is by definition. That's the algebraic definition, and I'm just kind of giving you another way to think about it. Cosine is nice. That's what I'm saying to you. Cosine of negative 5,000 degrees is the same as cosine of positive 5,000 degrees. And positive angles are easier to work with than negative angles. So for cosine and its reciprocal secant, cosine and secant, you can drop the negative sign and just evaluate the positive input. Easy peasy. Saves you time. Okay? So that's for cosine and secant only. So my next slide, boop, once again, I'm crossing stuff out just for the sake of this demonstration. Those are even functions, okay? So cosine is an even function. All of the others, sine and tangent, those are actually odd functions. Now here's what odd means, and I'm going to do another example for sine, and I'll say that it applies to tangent, and we don't have to worry about finding it. Sine, ooh, I think my battery on my pen is getting low. We'll fix that. So sine of 30 degrees. So sine of 30 degrees, and I'm choosing 30 degrees just because it's nice for sine. Sine of 30 degrees gives me a y value of 1/2. So sine of 30 degrees is 1/2. What is sine of negative 30 degrees? Well, sine of negative 30, remember negative 30 takes me clockwise away from the x-axis. Well, my y value there is negative 1/2. Okay, so here's what odd says. Odd says if you plug opposites in, you get opposites out. Okay, so verbally, opposites in give you opposite outputs. So it's kind of nice if you know sine of 30 is 1/2, then sine of negative 30 is just negative 1/2. So if you're evaluating a negative angle, think about what the positive angle gives you and change the sign. That's what this algebraic statement actually says. It actually says opposites in, opposites, you have to change one to make them equal. Okay? So if you're looking at that going, I don't know what that means, all that means is opposites in, you get opposites out. Okay? So sine is an odd function. Tangent is also an odd function. So if you're trying to evaluate a negative angle, think about what the positive angle would give you and just change the sign. For even, if you want to evaluate a negative angle, just drop it and evaluate it because it won't change the output. So negative 60 and 60 for cosine, an even function, both give you the same. Okay? So, all that to say, sine and cosecant are odd functions. Tangent and cotangent are odd functions. And only cosine and secant are even. All right, guys? Hopefully that helped you understand odd and even, but certainly helped you understand given one trig function value, you can find the other 5 if you know where theta lives. Start working those practice problems, and as always, send me any questions if you have them.